Good afternoon, everyone. Thanks for coming. So yes, I'm Julien, I live in Bristol. I run Digital Pebble, a small consultancy doing mostly green software and GreenOps these days. I've been involved in various organizations, so the Apache Software Foundation. I've worked on several projects there to do with search, web crawling, various things. I'm also a member of Boa Vista, which is an organization predominantly based in France, and I'll talk about Boa Vista later a little bit more. And I'm also a champion at the Green Software Foundation. So, yeah, this talk is a little bit different from the other talks you've seen today. As you said, I was the very first buzzwords. There have been probably 5 or 6 times in total. This is by far my favorite conference. And one thing I've noticed since my last visit to Buzzwords was that the number of AI-related talks at the conference. And we now have pretty much half the talks are AI-related in one way or another. So yeah, AI obviously is taking over the conversation. The environmental impact of AI is also, and data centers in general, is also becoming more visible. You literally can't have a week where you don't read in the press or anything something about the impact of data centers. So the awareness of the environmental impact is growing. What it means in terms of the cloud providers is that they have targets, they have commitments, they have things they say they'll do and achieve, but in reality, they are totally behind their targets, and it's getting worse and worse. In fact, some of them are already backtracking on their previous commitments. But the good news is that as a user of the cloud or as a technologist, you can make a difference. And the first step is to try and quantify the impact of your cloud usage. So I've been talking about AI so far, but in reality, although the use of AI is obviously growing, for a typical organization, AI is just a small part of the whole bulk of the whole cloud usage. Things like computation with EC2 or S3 and networking, etc., are still the main bulk of an organization's cloud usage. But having said that, you can already measure, there are already models that can help try and estimate the energy use of AI inference. The good news is you already have the data to do some of these things, and that's exactly what GreenOps is about. So you're obviously familiar with the term FinOps, and FinOps is about measuring and reducing the financial cost of cloud operations, whereas its twin, GreenOps, is about the environmental impact. They are two sides of the same coin in a way. They have loads of things in common in a sense that you use the same data for doing it, but also some of the activities, some of the actions you can take totally overlap. So things like if you eliminate idle resources, for instance, well, that will have both a positive impact on the cost of your cloud usage, but also on the environmental impact. Some measures are specific to FinOps, to the financial side. So if you get a discount or you make some commitments and everything, it will cost you less, but it will have no impact whatsoever on the emissions and everything. The other way around, you can choose a low carbon region that will have a massive impact on your emissions, but not change much to the cost of your cloud. So FinOps and GreenOps share loads in common. Effectively, in organizations, it's driven by the same team. We'll try and drive both the FinOps and the GreenOps. One other thing they share is the data requirements. So one thing which is absolutely essential is the tagging. So when you create a resource on the cloud, so it could be an instance, some storage and everything, you associate tags with that resource, so user tags. And that's how, as an organization, you represent that, say, this bucket of storage is used by team X for product Y, and say the test environment and everything. So that's how you can then attribute the costs of your different users, but also the impacts. It's absolutely essential to have that in place. So it requires a policy. You need to define, as an organization, what sort of tags you want to have, what values for these tags could be, And you also need to enforce these tags. So when something is deployed on the cloud, ideally, there must be checks in place so that they have the proper tagging. Without the tagging, you really can't do anything. So before we go into the more details about how to do GreenOps, let's cover a few key concepts first, just to equip ourselves with the terms and terminology. So the first one, and it's probably the most important one, is that of carbon intensity. So this is a screenshot from one of my favorite companies, and their website is just eye candy. I can spend hours just looking at the data, some electricity maps. So they provide information about the energy mix for different regions in the world, different countries and everything. So here we can see Germany, that was from last month or something, and it shows us that that particular point in time, what the electricity mix was. So there was quite a bit of solar that day, but also coal and gas. So you can see the intensity is probably medium. It's probably around 300 grams of CO2 equivalent per kilowatt, which is not as good as France. France runs on nuclear, which has lots of issues with it, obviously, but in terms of carbon emissions, that's relatively low. And then Sweden is mostly renewables, and Poland is still mostly coal and gas. So where stuff runs is hugely important, and that's what we mean by carbon intensity. Another important concept when you start looking at sort of carbon reporting and everything is the concept of scopes. So that comes from the Greenhouse Gas Protocol, which is a well-established sort of protocol for reporting emissions. And what that defines is basically that you have three scopes. You have three categories, so to speak. The first one, scope one, is your direct emissions. So let's say I'm a data center. My direct emissions would be if I have a fleet of vehicles on site, what's the emissions related to the use of the vehicles. If I have, say, gas turbines on site, then that's my direct emissions from those. Whereas scope 2 is the energy you import. So if you're connected to the electricity grid as a data center, the emissions don't really happen on site. They happen wherever the energy is produced. So that comes under scope 2. And scope 3 is basically everything else. And in the case of a data center, that would be, the impact of the building, but also the impact of the hardware, the drives, the servers, everything. So scope 2 has a bit of a twist, is that there are two ways of reporting it. The first one, location-based, is very much what we saw with on the electricity maps with the carbon intensity. So with a location-based approach, you report the emissions based on the carbon intensity of the grid at the place in time when you use the energy. But there's also the market-based approach, and that's where cloud providers take into account obviously the carbon intensity, but offset it by using things like power purchase agreements or buying certificates. What it means basically is that they invest in, say, a wind farm somewhere, and then when they report the figures, they take into account the energy that was generated on those things. But now is it greenwashing? Debatable. But now the recommendation is to use location-based. So what do we get from the cloud providers? What tools do they give us to estimate our environmental impact? So we'll have a look at AWS. So they have recently started the sustainability console. There was something different before. I think it was called a customer cloud something. But that's the new version of it. And what you get is this sort of dashboard where you get the emissions by scope. So again, 1, 2, 3, whether it's location-based or market-based. And obviously, location-based is you have more because you haven't done any of the offsetting. And then the breakdown is by service. And service has just like 4 categories. It's like EC2, S3, CloudFront, I think, and everything else. So you have only those 4 buckets, and then you can split things by geographical, like cloud region, or you can split by by scope, etc. You can also filter and export the data and everything. So they have made it better than it was. So yeah, lots of progress in the last 12 months. If I'd given this presentation a year ago, it would have been a different picture. So some of the things they improved is the latency. So before you had 3 months before you were getting the data. Now it's just only 1 month. It is easier to access. Before the carbon dashboard was part of the more of the billing side of things. So they separated it, so it makes it easier for people just to access this if they don't need the billing, etc. They have now added the fundamentally the location-based estimates, which makes more sense than the market-based one. Because before it was pretty much like everything's fine, you have no impact, it's all good, don't worry, still keep consuming our stuff. Whereas now you get a slightly clearer picture. Also, importantly, they've included scope 3, whereas before it wasn't there at all. And yeah, we get filters, we get a bit more visibility. So that's probably just about good enough for general reporting. If your organization needs to give like an annual figure of estimated impacts, that's probably fine. But the problem is the granularity of the data is still just a month. That's the smallest granularity, the finest granularity you'll get. As for the services, it's just this full bucket. It's very pretty broad. You can't see user tags at all. So if you've tagged your resources per team and everything, well, you don't have that, so you can't attribute the impacts to the different parts of your organization. So it doesn't give you any actionable insights. It is not a tool for GreenOps. You can't drive change through using this tool. So there are quite a few commercial providers for GreenOps that will give you better data and everything, but I'm an open source guy. I've been doing open source my entire professional life, so that's what I'll be talking about now. There's one important project which is called Cloud Carbon Footprint. That's backed by a consultancy called ThoughtWorks. They do multiple cloud providers, so the usual one plus many clouds. Multi-criteria, so they give you estimates for the energy, the carbon emissions, and obviously the costs. It's multi-stage, so you see the impact from the usage of the servers and everything, but also what's called the embodied emissions. So basically trying to estimate the emissions that went into, for building the resources, the hardware and everything. So the scope 3 we were talking about earlier. So you can drill down by cloud provider, account, service, time period, not by user tag again. So at the end of the process, you get something that looks like this. You get a graph showing your usage over time, the typical comparisons with flights and so on, and a breakdown per region, which reflects the carbon intensity I was mentioning earlier. So it is. It was for a long time the only tool and the reference tool for doing GreenOps. It is to some extent extensible, and you can customize it, but pretty hard to set up, very slow. But the main problem is that the data and methodology behind it are now quite outdated. And the reason for that is that it's not actively developed anymore. They've pulled the plug on it. So there are loads of things that are not covered, like there's nothing for AI, there's nothing for water usage or anything. So it was a great project, but it's not really useful anymore. So I started a new open source project, SPRUCE, around a year ago. So SPRUCE is open source, Apache license. So we now, I think last week, released 1.1, but don't be fooled by the version number. We've actually had 13 releases. It's just under a year, so it's been pretty active. And what SPRUCE is that it's an enrichment pipeline for cloud usage reports. So it covers AWS and now Azure since the last version. So under the bonnet, it uses Apache Spark. And what SPRUCE does is that it combines third-party data and libraries. So we try not to reinvent the wheel, but leverage existing resources. And we'll have a look at those in a moment. It's basically a case of standing on the shoulders of giants. And the idea is that we use the same data as FinOps, and we just add columns for the environmental impacts. We keep the FinOps and the GreenOps side by side, again, because in practice, it's the same teams sort of driving it in an organization. So the workflow in just one picture is this. So you get usage reports from the cloud providers. Those are massive files, CSV or Parquet files. Then you spruce them with Spark. And what you get at the end are enriched files, enriched Parquet files with the costs still there, obviously, but we also have estimates for water and CO2 emissions. And from there, with those Parquet files that you got, well, you're free to do whatever you want. You can build a dashboard, you can build reports, you can embed that in whichever way works for your organization. The idea is very much to make the data pervasive and everywhere, so that hard to ignore. Just to give people a way of being accountable, but also ways of taking action. So those usage reports, also known as CURs, they're just, as I said, massive Parquet files that are written to S3. And you configure those data exports through the Amazon, the AWS console, and you define what columns you want, what time granularity you want, whether you want hourly entries or daily, and so on. And obviously, the size varies a lot depending on what the granularity you choose, but also the size of your organization. So some of the typical SME, like the ones I work with, for a year's worth of data, that would be half a gig on S3. For a very large organization, like some of the ones that I've worked with are it's 600 gigabytes. And what those usage reports contain is just loads of millions of lines, where each line is an activity that you did on the cloud. So it could be like you've used that instance type for an hour, or you've stored like so many gigabytes, for an hour, etc., etc. So it's a long, fastidious, massive, number of rows like that in those Parquet files, and that's used essentially, primarily for FinOps, but now we can also use that as a starting point for doing GreenOps. So I mentioned Apache Spark, obviously a well-established project. And what we get from Spark is that we get scalability. It's designed to run at scale and process huge amount of data. So it's a really good match for us. Also, it supports the Parquet format out of the box and integrates with S3 and everything. So nothing to implement from our side. We get all that directly from Spark. And also, as being an important project like that, it has mainstream adoption. So you can run that, say, on AWS as a service. So really, really good tool. Concretely, how do you run Spruce? So you have different options. You can have, if you happen to have your own Spark cluster, sure, use that by all means. But having just downloaded Spark, you can just run it as a one node on your laptop. Also works fine. So there's a tutorial on how to do that with Spark. You can also use Docker. So we have a Docker image. You can just spin the Docker container, launch it, and enrich your CUR reports with Spruce. Or, as I mentioned, you can also use things like Elastic MapReduce from AWS, where it runs as a service. It scales to whichever size you want. But the beauty of that is that the data, in a way, never leaves your AWS environment. So for some organizations, they are a bit, they can get a bit worried about exposing their cost and usage reports to third parties. But at least with this, they can run it themselves within AWS. It never leaves that perimeter. So what's in Spruce? What modules do we have? So the main one, I would say, is something that connects to the Boa Vista API. So I mentioned Boa Vista before. It's an organization mostly in France where I'm a member, so we do data, methodology, and projects and code around green software in general. And the Boa Vista API is one of the projects at Boa Vista. And it's, as the name suggests, it's an API that gives you estimates for energy, embedded emissions, and also resource depletion, which is ADP, for different instance types of virtual machines and everything. So we have that, and obviously that's how we get the energy estimates for the computation side of the cloud activities. So you can connect it to an instance of the API. You can also, there's also a static version where we compile the data into a CSV file that's embedded in Spruce, so it makes it a bit easier to deploy. So yeah, Boa Vista API is a pretty key component of our stack. There are also things we borrowed from Cloud Carbon Footprint as a starting point. So we re-implemented some of the heuristics, we used some of the coefficients and data. And it's to do things that are typically not covered by the Boa Vista API. So storage, S3, GPUs, etc. So we ported their code pretty much like for like within Spruce, added data where there were gaps in CCF, but as I said, it's some of it's outdated. So it's probably progressively being replaced by slightly better implementations in Spruce. So our own modules, so we have things for networking, serverless, which again the CCF doesn't have that. The PUE and WUE coefficients, so that is the power usage effectiveness and water usage effectiveness. Basically, what this is, it's for data center, it's the overheads of the cooling and the water consumption that goes with it. So these the data are published by the cloud service providers, and we just use that. For the carbon intensity, so we saw electricity maps earlier, but we use a different data set called Ember, which is publicly available, and which has data about all sorts of loads of different countries and regions. So we use that within Spruce. And then we have our water module. And there are two aspects to the water. One is the water used by for the electricity production, so to make the electricity in the first place. Obviously, things like dams and stuff will use quite a bit of water, but also the cooling. So how much water goes into to cool the servers and things. And for the data for electricity production comes from a data set at the World Resources Institute. Now, if you don't know the World Resources Institute, it's a treasure trove of amazing stuff. They do some really interesting research, really, really good stuff. One of their projects is called Aqueduct, and it's a data set with information about different regions of the world, but the level of water stress in those regions. Because a liter of water in, say, Sweden doesn't have the same importance as the same water in, I don't know, Spain or South Africa or even in the US. So we use that to not just quantify the amount of water that's used by the cloud usage, but also where it matters. And that's something that's unique to Spruce. And none of the commercial sort of GreenOps providers do that. So open source for the win. We then have a module obviously for AI, and again leveraging existing solid open source projects. So we use data from Ecologits, which is part of Code Carbon, and that gives us sort of estimates for inference from 370 or so AI models based on the number of output tokens. So again, we're using this. We can connect to the API directly, but we also made like a snapshot of the data as a CSV within Spruce, so you can also deploy it quite easily. So we do cover AI, or at least the AI that is in your cloud usage. What do you get at the end of it? So you get, as I said, enriched Parquet files, and you can query them just with SQL using Athena or DuckDB, for instance. And a query would look like this. So some of the columns are columns like line item product code or service code. These are things that come straight from the usage reports, whereas operational emissions, energy usage, these are the columns that Spruce added. And then you can just build all sorts of queries that are relevant. You can split things by service, product, etc. We also have a, just again as a starting point, we have a little dashboard that people can use to show the, again, to query, I think it uses DuckDB under the bonnet, just to query the enriched curl reports and display them in a way that makes it easier for people to understand. So I will try at my own peril to show you what it looks like for real. So I'll try and put that on the other screen. Hey, victory. So this is a dataset from enriched curl reports from a partner of ours. So I've anonymized some of the fields, so I removed the cost fields and everything, which is why a few things are missing here. I also removed the user tags. So there's a way, on a non-filtered dataset, you would also see a breakdown per user tags, but obviously, can't show that here. And that's just a simple your dashboard, similar in a way to the one that Cloud Carbon Footprint provides. And it shows you the overall picture. You can filter by cloud region, by billing period, so month and year. And it gives you, that overview, that big picture across all the entire cloud reports. The trends over time, so for energy, emissions, water. The top emitters per service. So here it's obviously running ES2 instances is the main contributor to the impact. And then you get a breakdown per region with the water as well for all those different regions. So a very simple little dashboard, but something that can get people started. Again, the beauty of Spruce is that you enrich the data and then you're free to use those enriched reports whichever way works for you. You're not constrained into a specific dashboard or reporting tool. Speaking of reporting, so we also have a simple it's like report generator. So you point it to a set of enriched curl reports, and then you tell it to do an HTML report, PDF, or Markdown, and it will just produce a nice little document with pretty much the same information as we saw on the dashboard, but just as a file. Again, these are just starting points just to get something tangible easily. And the beauty of that is that, say, you use Docker and everything. If you have access to the data, within 5 minutes, not even, you can get a good understanding of what your emissions are, what your impacts are, because it's not just emissions, but also where it comes from and which teams or products contribute the most. Next steps. So next steps for Spruce as a project. So as I said, we've added support for Azure. Not everything's covered yet. We need to improve the coverage. So I expect in the next versions we'll be working on that. But we have the main bits, right? We have VM, storage, networking. Often these are the main contributors. Next, we probably will could cover other cloud service providers, Google Cloud, Oracle. One thing we'll do for sure is to support the Focus format. So Focus is like a vendor-neutral format for usage reports, and that's an effort from the FinOps Foundation, which is obviously the big entity behind FinOps. So they're promoting this format, and that's something we'll implement for Spruce. And what we want to do is also grow the community of users and contributors. What you can do next as a responsible technologist is, see if you can start a GreenOps practice in your organization, make the data visible to your teams. If your organization is large enough that there's a FinOps team, these are the guys you want to talk to, because they already use the same data. They probably already built various tools for exposing the cost and everything. You want to have them on board. They'll be the ones working with you on that. Obviously, the next best thing you can do is give Spruce a try. As I said, it's pretty straightforward. It's easy. It's open source. You can get things done pretty quickly. Okay. And then contribute to Spruce if you can. you can, and contributions come in different ways. It doesn't have to be code. It can be just giving it a try and making sure that the documentation makes sense, sharing problems you come across, sharing usage reports if you're able to do so. You can anonymize them to remove all the sensitive data from your reports, and just sharing that is a wonderful way of contributing, because it allows us to improve the coverage and see the gaps, the things that we've missed. We also have quite a few good first issues on GitHub where you can have a look at and see if you can help in some way. But another way you can help with all this is also to contribute to the underlying ecosystem. I mentioned the Boa Vista API. Well, that's where we get the data for the servers and the instance types and everything. Again, loads of ways where people can help with that by improving the data or contributing to those resources helps the whole ecosystem. So definitely a great thing to do. Now, I expect you'd be wondering, okay, what are the main things in practice I can do to reduce the environmental impact of my cloud activities? So I've compiled a few, the top 3 actions. The first one is, it's a no-brainer. It's obvious. It's remove the waste. You can get from the cloud providers, you can get recommendation reports, like optimization reports, and those will tell you the resources that are underused. So it could be that bucket that no one's ever touched in 300 years, or these 2 instances that are just spinning silently, for a test environment that no one's been using. Sometimes large organizations, up to an estimate that up to 20% of their actual resources are things they don't need at all, or never, or you needed at some point but forgot about. And these, obviously cost money, but it also has an impact. So these are, number one is kill the waste. And it's also an easy one to sell, to a team. There's very little effort. It's a low-hanging fruit to get rid of that. So definitely my top 1 action. The top 2 action would be something that some people have coined light switch ups. And that's simply the idea that it is similar in a way, but it's about not everything has to run all the time. You can have non-production environments or databases and things for testing and so on that no one's going to work on them at night or weekends and everything. If you can make sure that you have a mechanism in place so that these can just go to sleep when they are not needed. And that does make quite a massive difference. And of course, the other obvious one is move to carbon efficient regions. Like, so with the AWS, for instance, US East 1 is often used as the default value. If you spin something, and by default, it will probably run it there. The problem is the carbon intensity there in that region of the US is not great. It's around 384 grams of CO2 equivalent. Whereas you do the same thing in Sweden, that's only 35 grams. And just by running something somewhere else, you get like a 10 times increase or reduction in emissions. So this one's a bit more not necessarily easy to put in place, because if you have something already running, it's not that trivial to move it somewhere else. But definitely something to consider and have in mind for your next project. The stuff that you haven't deployed on the web yet, take that into account from the start. Is that, okay, you should approach it in this way and think, okay, is there a reason why I can't run that in Sweden? And often you'll find that actually running things in some regions like Sweden is actually also cheaper. So you gain both mostly on the environmental side, but also on the financial side. Thank you. So a few resources for if you access the slides later. There's been a very good report by the IEA recently about energy and AI, which is very thorough. I really recommend for you to have a look. The Green Web Foundation, which is an amazing organization, have also just recently published their State of the Fossil-Free Internet, which is quite a short document, but definitely worth a read. And then on the more practical side, I suppose, there's the Green Software Foundation has a practitioner certification. It's free, it's online, it takes probably a couple of hours to do. And a lot of the concepts there will be, I've already covered, but it gives you a very good foundation in understanding the concepts for green software. A couple of books as well, really recommend, and also 2 podcasts, Green.io and Environment Variables, that are treasure trove of awesome guests and very interesting conversations. And that's it for me. Thank you very much.
Thank you. Are there any questions?
Thank you for the presentation. I really liked it. Very interesting. So as I actually know about sustainability and GreenOps, I wanted to ask you about the SPRUCE project. So at the moment, do you know like if it works or it should work with open source database and maybe like something like, to create a dashboard in Grafana, something open source as well? Would it be compatible or?
Yes, so as I said, once you have the enriched Parquet files, you can build stuff on top of it. So with a Grafana dashboard, the way I would do it, I suppose I would probably, assuming the enriched reports are on S3, you could use Athena to query the reports on S3, and then from Grafana, just or maybe not Grafana, or whichever dashboard solution you want, query that way. Again, it's totally flexible in the way you do it, but you can definitely do it that way. Yeah.
Right, and if I'm not using any cloud provider, would it still work?
No, so for SPRUCE it's very much, there are other resources you can use to, if you have stuff on premise or anything, like I mentioned Boa Vista, that's a good starting point. But SPRUCE is very much based on enriching those usage reports from cloud providers. But there are definitely other tools that can be used for on-prem.
Right. And one last thing was like, I mean, obviously I'll check it out the project. I also gave a talk about sustainability, about the SCI, the software carbon intensity applied to observability. So I really like to pick your brains afterwards to talk about that. Yep,
by all means, thank you.
Thank you. Let's check the time. Sorry. Yeah, 30 seconds.
Quick question then. Do you think with the push from people like us to go to more like a location-based monitoring instead of like the market-based, that we will also push providers away from making these agreements and actually buying these offsets because they don't really show up anymore in the dashboards?
I mean, those offsets and everything also have a value in a way, because that's really helped investments in renewables. And I think, especially in the US, a lot of solar or wind resources have been deployed using those mechanisms. Will it change? It's not really, I think, I'm probably quite pessimistic with that. The way it's going at the moment is that all the new data centers being built are not even connected to grid. They are off-grid using gas turbines and everything. So we're not going towards more observability and openness and everything. Things are afraid closing again a bit.
So thank you very much, Julien.
Thank you.
Yeah, and enjoy the rest of the day.